Git repository.
But that was the DevOps. In AWS, what was the last topic? Git repository was in DevOps. AWS last
So
topic.
load balance.
Load balancing, yes. So I have told you there are 4 different type of load balancers, and out of that, the first one is the classical load balancer, which is deprecated, and the second one is the application load balancer. So we have executed the classic load balancer as well, and we have seen how we can add the conditions in the application load balancer. So as per our requirement, okay. So if you want to have some constant coming in into URL, where what response do you want to have, so you can better customize the URLs and customize the basically the EC2 instances based upon the load. So, and the rest of the 2 instances are there, though load balances are there, that we'll be discussing in our today's session. So let me share the screen. Give me a second. So okay, so this is load balancing. So we have the elastic load balancer, which is going to scale up and scale down as per the request received by the user. So this is done, and then we have the health check signals is also done. Yes, types of load balancer on the AWS. So AWS has the 4 kinds of the managed load balancer. The first one is a classical load balancer, but this is important what type of traffic it is going to help. Okay, so this is going to have the secure TCP connections. It was established in 2009, which is called as the CLB, Classic Load Balancer, which is deprecated and outdated. Still it works, but it will be retired in September 2022. After that, it will not be working. Then we have the Application Load Balancer, which is a version 2 and a newer generation, and which came into existence in 2016. The third and the fourth one are the newer one. So network load balancer came into 2017. Protocol that is being used is TCP, TLS, and UDP protocols. So in network layer 4, it is going to work, and at layer 3, this is going to work gateway load balancer. Okay, so network load balancer and gateway. By the way, gateway load balancer is beyond the scope, and this network load balancer will not be executing because this does not fall under the free tier. So this is a paid one. So this is paid. So will not be executing either of this one, neither network or gateway. But I can assure you this: the network and the gateway load balancers, and gateway load balancers or the network load balancers, what is going to happen? The balancing of the load is going to be based upon the IP addresses. So based upon this, let me start with the whiteboard so that I can explain you. Give me a second. Okay, so since we need to discuss the network load balancer, but if it is a network load, uh, network load balancer. So how this is different from the application load balancer? Suppose we have NLB here, and the traffic is going to come from this site, and there are multiple users that are here. Okay, so there are multiple users that are here sending the traffic. Now this can be further categorized into two type. Okay, so either this can be given directly to EC2 instance. So this can directly be given to the EC2 instance, or you can have a IP address. So you can have a IP address to IP address. Let's suppose that there's a dedicated server is there. Okay, you have offline server that is being deployed here, and this network load balancer can have, this is the public IP. So this is the public IP that is allocated to this server. Now network load balancer can either forward your queries to the this EC2 instance. This can be EC2 instance, or it can directly send the network to particular IP address. Now why NLP, this network load balancer, is going to send to the particular IP? So maybe you are not using the EC2 instances and you have the offline, or you have a dedicated server at your offices. Okay, so whatever the traffic is being generated for this network load balancer, you want to have it onto dedicated whole machines that you have deployed into your offices. So we can use the public IP address to forward the traffic originating from the network load balancer to this the servers. So this is one of the point. Now, coming on to the next one. Okay, so overall it is recommended to use a newer version of the load balancers as they provide the more feature. We have studied this already. The next point is that load balancer security group, it works on the TCP, different layers that we need to provide access. We have discussed this already. Now HTTPS, this is point the host name, and the DNS name is going to look something like this. So you'll have the few characters here, then the region name AP South 1A, then ELB Amazon AWS.com. So we have seen that as well. Okay, application load balancer done. So this is from the World Wide Web, the traffic is going to be originating, and this is user is going to request that we have the external load balancer application which is going to forward the traffic, and this is going to be HTTP forward the traffic to the different target groups. Now target groups are further used going to have different EC2 instances based upon where you want to land your queries. Now user might be searching something, so this is going to be the one of the target group when the user want to search something. So target group for the search application, so this will be the two applications, and target for the users application. So if they want to assess certain kind of application, so we'll have a different target group. So we can, as we have seen in the last session as well, so we can create the different target groups based upon our requirements. If you remember, we have created instance A, instance B, and instance 3. So 3 instances we have placed it into the 2 different target groups. So this is how the application load balancer is going to work. So in application load balancers target groups, EC2 instances can be managed by an auto scaling group that we'll see today. What is an auto scaling group? So HTTP. Now EC2 task managed by EC2 itself, which is HTTP lambda functions that will be discussed in the coming lectures. Request is translated to the JSON document. So whatever request you are going to do, it will be internally translated to the JSON document. Then it will be sent to the load balancers. Then we have the IP addresses, must be the private IP. So these are the 4 ways in which the target groups can be created. Now this application load balancer ALB can route to the multiple target groups. So one query can be routed to the different target groups, and the health checks at the target level are very important. Okay, now external load balancer question mark if platform is equal to mobile, you will see that we have created multiple target groups. So if you want to reroute your query to the different place, so from external, this user is going to send a request, it will go to this external load balancer, which is basically your ALB, application load balancer. Now from this application load balancer, there are multiple options where the query can land. So if question mark if platform is equal to mobile, I want to send it here. If question mark platform is equal to desktop, I want to have it here. So based upon the requirement, we have created 2 different target groups. So target group 1 is going to be composed of AWS EC2 based instances and target 2 on-premise private IP routing. So whatever the requests are coming, if it is originating from the desktop computers, so I want to reroute to it my office computers and the office servers instead of EC2 instances. So this is based upon the requirement to requirement, and this is based upon the requirement of the company, how many target groups and what type of target groups are being required to be created. Okay. Now client IP address, connection to the temporary and load private IP address. Now this client to this ALP, this is this space is encrypted with the public IP. Okay, so this is 12, 34, 56, 78. This is the public IP address using which any client, any user, mobile user or desktop users will send the request to the ALB. Okay, now from ALB to the EC2 instance, this is what is happening within inside the AWS. So we are going to use the private IP address. So this load balancer can refer to the EC2 instance with the private IP. It need not to have the public IP. Okay, where do we need to have the public IP? If the client directly wants to go to the EC2 instance, which is by the way not recommended, in that case you need to have a public IP. Otherwise, this ALB and EC2 instances can communicate each other with the private IP addresses. Okay, then comes the network load balancer, as I have drawn the diagram. So in the network load balancer works on the layer 4. Okay, so this might be important when you'll be giving for appearing for the AWS certification on what layer each of this load balancers is going to work. So this works on layer number 4. It forward the TCP and UDP traffic to your instances, handle millions of requests per second. So since it is a network load balancers, so latency can be nearly equal to 100 millisecond. Okay, versus 400 millisecond ALB. Now how this is better as compared to the application load balancer? Better latency, जो delay है in this case is near about 100 millisecond, which is very less as compared to the 400 millisecond for the application load balancer. So in that case, it is very better and best for the application where you need to have a very less the latency. In that case, you can use the NLB. By the way, this is a paid, we cannot practice it into the free account. Okay. Now this network load balancer has one static IP per availability zone. Now as you change this static IP for the one availability zone, you change the next availability zone, you'll have the another static IP which can be added with your elastic IP addresses. So this network load balancer has one static IP and support the assigned. See, it is written assigning elastic IP, helpful for whistling specific IP. That means if you have been assigned one static IP address per availability zone, that you can assign with the attach with the elastic IP, so that even if you turn off the instances, you do not lose the IP address and you need not to start with the new IP address, new public IP address. Okay. Now network load balancers are used for the extreme performance in case where you want to have a very less latency. In that case, very extreme performances, you need to use a TCP and UDP traffics. Not included in, see, this is important. I was telling you, not included in AWS free tier. So this in free tier account, this does not included. So will not be practicing, but you just need to have a clarity how this is better as compared to the application load balancer. Now, in this case, if you'll see the network load balancer V2 TCP layer 4 based traffic. So you are going to have TCP plus rules and TCP plus rules from the outer world. Is requests are going to be received by this load balancer, network load balancer, and it is going to reroute the queries based upon the protocols from where it is originating. So if it is coming from the TCP, you will be directed to the different target group, and if it is originating, if the query is coming from the HTTP server, so you'll be directed to the different target group. Okay, so that is how this is going to work. Now network load balancer target groups. Now network load balancer, see this diagram I have already made. Target group. Now network load balancer, it can target in 3 different ways. So there are 3 different points. Now network load balancer target groups are either based upon EC2 instances. That means if this is the network load balancer, this can forward the traffic to the EC2 instances. Okay, this is one way. This is the instance side is written. So network load balancer can directly send traffic to the instances. That is first case. Second, it is written IP addresses must be private IPs. So this network load balancer can also send a traffic to the EC2 instance private ID and this public ID of this server. Okay, so you need to send it to the IP addresses. Either you can directly send to the instance ID. So this is the instance ID. So the network load balancer are directly sending traffic to the instances. This is one way. Second is you can send it to the IP addresses. So this is the second way where you are sending the traffic to the IP addresses. Okay. Third one, you can send the traffic to the again target group. Now, network load balancer can send the traffic to the application load balancer. Can you tell me why does we need to have this? Why we need, where we will need to have this? That one load balancer, which is network load balancer, is sending a traffic to the different load balancer, which is application load balancer, because we want to have the services of both the load balancer, whatever traffic is coming to the this network load balancer. So if I want to have a very high performance and if I want to have a very less latency, I'll be using network load balancer. What will be filtering out from the network load balancer, I'll be allocating. Sir, you are presenting the Jamboard or PDF notes? I was presenting better the PDF notes. Are you able to see this? Is my screen visible now? Is it visible now? Please, anyone confirm? Not visible? Yes, now visible. Okay. Okay, perfect. Okay. So we were discussing the network load balancer, and I was trying to explain you the difference between the application load balancer and the network load balancer. The first point that I have discussed is that this can forward a traffic from the TCP UDP traffic to your instances. That means it can be either originating from TCP or UDP. Okay, that works on layer number 4. This is the OSI model layers, and on what particular layers this network load balancer is working. Second is it can handle millions of requests per second, so it is extremely fast. So where we need to use it? On all the cases where we need to have an extreme performance, there we need to use this case. Then it is obviously going to have a less latency. It is given 100 millisecond as compared to versus 400 millisecond in application load balancers. So what we can conclude from here, that the latency or the delay in case of the network load balancer is comparatively very less, 1/4 as compared to the application load balancer. So wherever you need to have an extreme performance, there we use the network load balancer. And it can has the one static IP address as per the availability zone. So if you have the network load balancer in different availability zones, suppose AP South 1, AP South 2, AP South 3, if they are different availability zone, so in that case, for per availability zone, we will have the one static IP address, okay, which can be, of course, added to your elastic IP addresses, so that even in case you put down your instances, still you have the IP address attached to it. So network load balancers are used for the extreme performance. This is done, and obviously I was discussing this is not included in AWS free tier, so this is not recommended to practice at your end. Now, network load balancers, TCP, how it is going to work? Now, let's suppose, but we have been getting the request from different IDs from different devices and from the different protocols. Now, if it is generating from the TCP, HTTP, and HTTPS from multiple devices, we are getting the request. Now, this network load balancer, this can segregate the traffic based upon the protocols. How it is going to segregate? Suppose if it is coming from the TCP protocol, so you'll have a different target group for the health check, and if it is coming from the HTTP, so for that purpose you will have the different target group. So it can segregate the requests that are originating from the user based upon their protocols. And this is the slide that I was explaining you. that network load balancer target group. So whatever target groups we have written here, so these are the target groups that we have written here. On what conditions we can make these target groups, how we can make these target groups. And even though we have already made the target group in the last AWS class, but still there are three different type of target groups that you can make. The first type of network load balancer can send a traffic directly to the EC2 instances. So these are the two EC2 instances where the network load balancer directly send a traffic to this instances. You can see here there the instance IDs are written. Okay, so this is the one of the way. Second way is this network load balancers. If you don't want send it to direct instances, you can send it to the particular IP addresses. Okay, so there's the second way that you can reroute the traffic to the IP address. So this is the private IP address. Okay, so this is a private IP address, and this is the 10.0.4.21. This is a public IP address for the this particular server. Now this black colored server, this might be not present on cloud. This might be on premise. Okay, so if you're using AWS and you're using the network load balancer, but for a specific set of queries, you want to reroute it to the offline or the on-premise servers, you can do that as well by providing the specific IP address. So from next times onwards, so whatever traffic's originating, let's suppose if I'll say the traffic is originating from TCP protocol, send it to the private IP address for this EC2. Okay, and if it is originating from HTTP, send it to this public IP address because I want to manage it offline onto my office. Okay. The third case is network load balancer and might send a traffic to the target group, which can again be your application load balancer. Okay, so network load balancer can be can send a traffic to the application load balancer. So I was trying to ask you, what is the purpose that why one load balancer is sending a traffic to the different load balancer? What can be the reason for this? Any idea? But what can be the reason for this? See, if you want to have the functionality for both the load balancers, so if you want to use the network load balancer for the extreme performance, if because the latency is low and it is going to take much faster for the computation and for processing, you will be using the network load balancers. But ultimately, if you're sending it to the application load balancer, that means you want to have a different target groups that you want to create as per the application load balancer. So if you, in case you want to have a functionality for both the load balancers, you can send the traffic from one load balancer to the another. Ultimately, what is going to happen? This application load balancers will further be connected to the EC2 instances or the servers. Okay, so that can also be one of the case. Now coming on to the next one, that is the gateway load balancer. The next one is gateway load balancer. Now this is beyond the scope of the syllabus, but we still need to understand how this gateway load balancer is going to work. Better first of all, we'll try to understand with the help of this diagram, then I'll explain you these points. Okay, now let's suppose there are some users, okay, and this is going to be your source, and they are sending their traffic to this gateway load balancer, and for that they are using the route table. They are going to have certain route table where the source IP addresses are going to be stored. Now this traffic is going to be sent to the gateway load balancer, and there is a target group which is going to be the third party target group and the virtual devices. Now what virtual devices you can have it here? So these virtual devices can be security systems, it can be packet inspection systems, or can be the intrusion detections. So it can be anything that can be applied here, the target group. First of all, it is going to reach to the gateway load balancer. It will send for the filtration process into the target group. Here beta बहुत सारी चीजें हो सकती हैं, firewall, intrusion detection, system check, packet analysis, manipulation. Lot of things can happen. And if it is not healthy, now whatever the traffic is coming from the user, if it is deemed to be not healthy, it will be dropped here. Okay, it will be dropped here, it will not be processed. But if it is healthy one, so again the target group is going to send a traffic back to the gateway load balancer, and then this traffic is going to be sent to the application. So that is how the gateway load balancer is going to act as an intermediate between the user and the EC2 instances. It is going to the filtration process. This EC2 instances that you see here in the target group, this can be the for the checking lot of things like security, intrusions, and packet analysis, inspections, payload manipulation. For anything you can use this. And by the way, this is already written here. So you can deploy, scale, and manage a fleet of third-party network virtualization applies in AWS. Let's suppose in your organization you have been using certain kind of the security mechanisms like firewalls. Okay, now before your traffic can go to the application, you want your traffic to go first of all through firewall, then only it can reach to the application. So in that case, we can deploy the gateway load balancer, which is going to take some requests from the user through the route table. This is the route table, and it is going to have the filtration process. After everything is going to be okay, then only it can reach to the this AWS EC2 instance, which is going to be a destination. So it operates at the layer number 3, which is your network layer, and it is going to track the IP packets that are generating from the users. And it combines the following functions. That is the transparent network gateway and the load balancer. So transparent network gateway is this one, and the load balancer is going to be this one. Okay. It is using the Geneve protocol, which is on the port number 6081. So this is the another information. And so gateway load balancer target groups can be generated based upon the two things. The first one is going to be the EC2 instance. The second one is going to be the IP addresses. Okay, must be the IP addresses. So directly gateway load balancers can send it to the EC2 instances written in the diagram, or otherwise it can send to the private IP address for the different target groups. So this is done. Coming on to the next topic, that is the sticky sessions. Okay, the next topic is going to be sticky sessions. Now sticky session means better. Okay, do you have observed better then when we are going to do some banking transactions, and if you are not able to perform some action for a certain time duration, the session goes timeout. Okay, have you observed this thing, the session timeout? How many of you observed this, the session timeout for any request that you generally this happens for the sessions where we need to have a high security. So if you're doing some banking transaction, online transaction, and for few minutes, if you do not perform any action, automatically you'll observe that you need to reload the page because there's a session timeout. That's exactly what we are going to study in this sticky sessions. Beta sticky sessions, first of all, do you understand कि network, if it is a load balancer, beta client 1 if it is going to get a request, so बेटा वो इस instance के पास भी जा सकता है, इस instance के पास भी जा सकता है. Similarly, client 2 request can go to this instance also, this instance also. Client 3 request can go to EC2 this instance also, this instance also. But sometime when you want to have a session with the same EC2 instance, suppose client 1 send a request to the load balancer and ultimately it is allocated this particular instance. Okay. Next time again client 1 send a request to the load balancer. When if I want to have the same EC2 instance, then we need to use the sticky nodes, because generally this is the randomized, because load balancer is going to randomly allocate the different requests to the different EC2 instances. But if you want to have this client 1 twice it has requested and both the times it has been to the same EC2 instances, so that the session timeout doesn't happen. So in that case we used to have the sticky sessions. Okay, for the longer duration sessions we need to have the sticky session, which is called as the session affirmative. Now it is possible to implement stickiness so that the same client is always redirected to the same instance behind the load balancer. So that's the only purpose, that if one client, I don't want everyone every time to change the instance. Every time I want to move to the same instance, so I can have the sticky session. So this works for the classic load balancers as well as for the application load balancers. For both the load balancers, this sticky sessions can work absolutely fine. Okay. Then we have the cookie. This is used for the stickiness as an expiration date you control. That means a cookie used for the stickiness has an expiration date you control. So after how much time you want to expire this cookies, you can control this from 10 seconds, from 1 minute to 10 minutes to 1 hour. For that you can decide with the help of the date and the time frame. So use case, make sure the use doesn't lose this session data. Where you want to use this, but sticky sessions kahan pe use hote? So use cases, make sure the user doesn't lose his session data. For all those sessions where the user, we don't want user to lose the data, but otherwise what is going to happen? Let's suppose client one request load balancer and it has got this instance. For half an hour, client one was working on this, and because of session timeout, client one again make a request, and it next time it goes to this EC2 instance. So by doing so, there will be a loss of data. Okay. So where we do not want to have this, we can use the sticky session. So every time client is going to make a request, it will end up having the same EC2 instance which has already the data stored into it. Okay. So there is that is the particular use. Now, it can enabling stickiness may bring imbalance to the load over the backend EC2 instances. Of course, but enabling stickiness, these are directly proportional. If you enable stickiness, it brings imbalance to the load. So if client one is always going to take EC2 instance, so obviously load balancer needs to put extra effort for managing client 2 and client 3, which will be redirected to the this particular EC2 instance, which create an imbalance. So this is inversely proportional. So if you have the sticky sessions, which will create an imbalance on the load balancer. So this is important one. Then sticky notes and the cookie names, you can have the different names for this one. Try to read it once. Better read it once. Okay, I hope you have read this. And the cookie names are given based upon the application based cookies. दो type के cookies होते हैं. There are two types of cookies. First one is the application based cookies. Second one is the duration based cookie. For what duration you want to have it. Okay. And in application based cookies, we have the custom and the application cookie. Now, when you use the custom cookie, you can generate the target group. You can include any custom attribute required by the application. Cookie name must be specified individually for each target group. So if you have the two target groups, so need to specify two different cookies for the each target groups. And what are the names that are reserved keywords that we cannot use? So AWS, ALB application load balancers, AWS, ALB app, AWS, ALB target group. So these are the few of the names that are reserved already. So we cannot use this. Don't use these words, reserved for the use of the elastic load balancers. Then we have the application cookie, in which you need not to specify all these details. We need not to customize this. This is already there. So you can generate the load balancer cookie name with the AWS ALB app. This will automatically be created. Okay. The next one is the duration based cookies. Okay. Duration based cookies are cookies generated by the load balancers internally based upon the time frame, जो कि कुछ particular time duration के लिए active रहेंगी. Cookies names will be AWS ALB or ALB AWS ELB or CLB. Okay, so these can be the by default name for the duration based cookies. Okay, then cross zone load balancing. This is an interesting topic, cross zone load balancing, and this have the two distinction between it. Okay, cross zone load balancing, first of all, better try to look onto this one without a cross zone load balancing. Now let's suppose there is a machine. Okay, this is a user machine and it generates the 100 requests. Okay, this is a user machine and it generate 100 requests. So 50 requests here and 50 requests here. So this is one of the load balancer, and in this load balancer, only two EC2 instances are connected. This is also one of the load balancer, and in this load balancer, four EC2 instances are connected, but this is onto the different availability zone. Now, if you do not have the cross zone load balancing enabled, okay, if you do not have the cross zone load balancing enabled, so requests are distributed to the instances of the node for the elastic load balancer. So that means if 50 are going into one availability zone, better if this elastic load balancer, if 50 are coming to this, 25 will be given to this for processing, and 25 requests will be given to this instance for the processing. Okay. Similarly, if 50 requests are sent to this elastic load balancer, which is in the availability zone Z2, then each one will be having the equal division of the requests for whatever instances are attached. So if 50 was there, so 6.25, this is generally, you cannot have 0.25 requests. This is general for the understanding purpose. Okay, the query cannot be in 0.25. So this will be evenly distributed into the availability zone. So this is the meaning of the without cross zone balancing. Now coming with the cross zone balancing, what is going to happen in this one? So read it, each load balancer instance distribute evenly across all the registers instances in all the availability zone. Better no matter if 50 requests are going to be here or 50 requests are going to be here. Okay, now if 50 requests are going to be here, okay, let's suppose if 50 is coming here, so it is going to take 10 and 10 here, and rest of the instances are going to be given here. So even though they are present into the different availability zone, so if you have this, the cross zone balancing enabled onto it, whatever whatever the nodes are associated across multiple availability zone, it will get evenly distributed. And of course we can say this, that the balancing is going to be more preferable in this case as compared to this case. Okay, so we will be using availability zone 1, availability zone 2, and the balancing is going to be happen more conveniently in this case where the cross zone balancing is enabled. Okay, the next one is cross zone balancing, and it can be applicable to the application load balancer, and it is always on in case of application load balancer. In network load balancer, but it is disabled by default. You need to pay if you are going to transfer the data from different availability zone. In classic load balancer, this is disabled by default, and no charges for the if you want to travel and if you want to send data from one availability zone to the another availability zone. That means the application availability zone applicable load balancers, it is always on. Network load balancer mein this is disabled by default. Classic load balancer maybe this is disabled by default. In this one, no charges will be there even if you move the data from one availability zone to another availability zone. Network load balancer mein you need to pay the charges if you move the data, and classic load balancers no charges were there. Okay, so these are three distinctions for the cross zone load balancing. The next one is SSL and TLS basics. So whether you have studied the computer networks, but do you have studied the subject computer networks? Is there anyone who has studied the subject computer networks? Yes. Okay. So can you differentiate between SSL and TLS? You might have studied this already. Yes. Can you discuss this? So these are the very basics for the SSL and TLS that of course we'll be using in upcoming lectures in the practicals. So an SSL stands for the secure socket layer. SSL का full form क्या है? SSL stands for the secure socket layer. SSL certificate allow traffic between your clients and your load balancer to be encrypted in the transit. So that means from source to destination, whatever data is in transit, that means that the data which is traveling, उस डेटा को बेटा सिक्योर करने के लिए you use the SSL certificate. And in-flight encryption, we call it as a in-flight encryption because when the data is in moving state from the end user to the load balancer, उसके बीच में when the data is moving, it needs to be encrypted so that it cannot be read by someone unauthorized person. Okay. Now SSL refers to the secure socket layer we have studied, used to encrypt the connections. This is done. TLS is the transport layer security. Again, this is the security mechanism which is a newer version. This is the newer version of the SSL which adds a security at the much deeper level at the transport layer level. Okay. Nowadays, TLS certificates are mainly used, but people still refer it as a SSL. So TLS certificates are the mainly nowadays it is going to be used, but it is, since it is an advanced version of SSL, people still prefer calling it TLS as the SSL. अभी भी लोग TLS को SSL से ही refer करते हैं because this is the conventional one. So we also be referring it with the SSL. Okay. Now public SSL certificates are issued by the certification authorities. अब ये certificates issues कहाँ से होते हैं? From the third party organization like Komodo, Sysantec, GoDaddy, GlobalSign, DigiCert, Let's Create, etc. So these are the few of the organizations that can issue the SSL certificate that are required for a user to be encrypted when they are sending their request. Coming on to the SSL certificates have an expiration date. Okay, so they generally come with the expiration dates. 1 साल का, 2 साल का, इस तरीके से they used to have the certificates and expiration dates. Now, as long as it is valid, you can use it. But if SSL certificate is going to expire, you need to purchase a new one or you need to renew it. Okay. Coming on to the load balancers SSL certificate, how this is going to work. But very easy. This is the user, this is the load balancer, and this is the load balancer, and this is the instance. Now, between user and load balancer, this is called as a public space. ये एक public space है. So we need to encrypt the data. See, we have used, instead of HTTP, we have used HTTPS, which is a secured channel. So it is encrypted. So user can use the HTTPS to send the data to the load balancer. But once the data reaches the load balancer, beta internally, so within AWS, you will use the simple HTTP, which is unencrypted. तो ये जो डेटा है यूजर से लेके लोड बैलेंसर तक जब ये डेटा आएगा तो ये एनक्रिप्शन की फॉर्म में आएगा बेटा. दिस विल बी एनक्रिप्टेड फॉर्म. But once it reaches at the load balancer over the private VPC, so you can use the HTTP, which is the unencrypted one. So no need to have an encryption performed here. Okay. So let's read the points. So the load balancer uses an X.509 certificate. So this is the internal certificate used by the load balancer, and which is the form of the SSL and the TLS server certificate. Okay. Then you can have the second one is you can manage the certificate using the ACM, which is called as the AWS certification manager. आप बेटा खुद के certificate भी upload कर सकते हैं, which will be loaded into the AWS certificate manager, and you can create and upload own certificates alternatively. Now AWS जो HTTPS listener, this is going to perform the following task. It must specify the default certificate. If it is available, it need to specify default one. You can add an optional list of certificate to support the multiple domains. Client can use the SNI, server name identification. Very very important topic जो कि हम अभी पढ़ने वाले हैं, server name identification, to specify the host name that they reach. Fourth one is ability to specify the specific policy to support older versions. So HTTPS server that you will be using, it can not only work with the updated one. So even if you use the older versions of SSL and the TLS, in that case also, this listener can perform absolutely fine. Okay. The next one is SSL server name identification, SNI. What is server name identification? Try to read this once. Have you read this? So beta server name identification और सर्वर नेम इंडिकेशन SNI बहुत इंपॉर्टेंट कॉन्सेप्ट है. What is going to happen in this? Let's try to read it through the diagram. So there's a client. Okay, this is the application load balancer ALB. Load balancer is going to be there. Now, if this is the one target group, this is the another target groups. Now, client would request along with the URL, they can specify SNI. They can specify the server name indication that they would like to, because ALB is going to randomly allocate the server. Okay. But if a user would specify explicitly that I want to have one particular type of server, I want to reach it, for that, beta, we need to use this particular certificates. Okay, so we have the multiple certificate. So let's suppose there are two target groups with the name mycorp.com. This is one of the target group. Second target group is domain1example.com. So let's example is these are the two target groups, mycorp.com, domain1example.com. So obviously if we have the two target group, we have studied already the previous slide. For multiple target group, we need to have the multiple secure socket layer certificate. So we have SSL1, SSL2. Okay, so SSL certificate for domain1example.com, this is there. And for this target group, we have another SSL certificate, which is mycorp.com. So for every target group, I have the different SSL certificate. Now, when the user is going to request, if it includes in the within the URL that what particular target group it wants to have, the same query will go to the ALB, this application load balancer, and this application load balancer will go to the SSL certificates, and it will identify that okay, user has requested for this mycorp.com, this particular security group. So based upon that, the traffic will be going to the target group, which is mycorp.com. So this is also one of the way where SNI, using the server name indication, you can specify on which particular target group you want to reach. So this is again given on this, the notes it is given. SNI solves the problem of loading multiple SSL certificates onto one web server. That means it solves the problem of loading multiple SSL certificate onto the one web server to serve the multiple website. We can load it into the different one. So this is not a problem anymore. It uses the newer protocol and it requires a client to indicate. So second point is very important. It's a newer protocol and it requires the client to indicate the host name of the target server in the SSL handshake. So in this handshake process, they need to explicitly mention within the URL that what particular host name they want to reach, and based upon that target group, the query will be rerouted. The server will then find the correct certificate or return to the default one. If it is present the correct one, the server ALB is going to return it, or otherwise the default the SSL certificate, whatever is present, the query will be returned to the default one. Okay, now only works for the ALB and the the topic that we are studying. This will only work for the latest one, either with the application load balancer or for the network load balancer, which is your newer generation. And of course with the CloudFront, that is the one of the application for AWS that we'll be discussing, and does not work with the classic load balancer since it is of the previous generation. Okay, then the elastic load balancer SSL certificates. Okay, now classic load balancers support only one. So it support only one SSL certificate and must be multiple classic load balancer for multiple host name with a multiple SSL certificate, because one certificate will be supported one classical load balancers. But this is not the case for the application and the network. In case of application load balancers, multiple listeners can have the multiple SSL certificate, and same is here. Multiple listeners can have the multiple SSL certificate. In this case as well, ALB के case में भी use server name indication to make it work. And in this case as well, you can use the server name indication to make it work. So that means it is exactly same in case of application load balancer as well as the network load balancer. Okay, so then we'll have the connection draining. Okay, connection draining. Now correction training beta, in case one of the instance don't want to take any traffic further. Now suppose this is live from 10 hours, this is live from 5 hours, this is live with from 2 hours. Now this has already been working from 10 hours. Now this instance wants to stop taking the request. So it can go into the draining mode. Okay, it can go into the draining mode. But when it is into the draining mode, whatever the queries are already present within this instance, first of all, it will complete all those queries. Then it is going to shut down. Okay, so draining mode matlab it is going to send a signal to the load balancer that it does not want to take requests any further, that it is into a draining zone. Now this is smart enough, this load balancer is smart enough, when it gets a signal of a draining from one of the instances, it will allow this instance to work for whatever the requests are already pending with it, and it will not allocate any new uh, request to this instance, or rather than that, it is going to forward all those queries to the rest of the instances. So that's a draining mode. Okay, so waiting for existing connection to complete. So if it is a draining mode, so it is waiting for the existing connection to complete before it gets shut down. And in case of this one ELB new instance, new connection established to all other instances, not of this instance but all other instances, it can establish a connection. Now what is written featuring name? So beta, if it is if you are using the CLB, it is called as the connection draining. The name is connection draining, but if you use the ALB and NLB for the newest version, but the name has got changed. So instead of connection draining, we called it as a deregistration delay. Okay, deregistration delay, we referred it in case of ALB and NLB. Next comes the time to complete. Okay, now time to complete in-flight request while the instance is deregistering or unhealthy. If it is going to unhealthy or if it is deregistering, so whatever in-flight requests are there, in-flight request kaun si hongi? Beta, that has left the ELB, but that is yet to reach this particular instance. That means which is on their way. So it is going to process all those instances before it is going to drain out. Now it stops sending new requests to the EC2 instance, which is deregistering, and you can have sent the draining time anywhere between 1 second to 3006 seconds. Default is 300 seconds. If you want to deregister very fast, now for example, the queries that you are handling, if it is very short queries, okay, so if it is very short queries, you need to limit this deregistration to probably the lesser value, suppose 10 second, 20 second, like that. But if you're dealing with the request that is taking longer time to process, so in that case I'll be having this the deregistering time, I'll increase the time to 100 seconds and 150 seconds, and like that. It can also be disabled. If you set it to 0, that means the draining is going to be disabled, so a node will not be allowed to drain out. So it can be set to low value if your requests are short. This we have discussed. So if you are processing the shorter request, you can set the value to the lower one. Okay, then we have the auto scaling group. Okay, so auto scaling and group AWS beta, from this point onwards we'll try to have a discussion in our next class. Okay, so today we'll be wrapping up our class here only. We'll have a 1 hour session today from 6:30 to 7:30. So we'll be closing our session here only, and from tomorrow we'll be starting with the auto scaling group, and we'll be seeing a lot of practicals coming up tomorrow in our class. Okay, so stay tuned and please try to join the classes regularly. And there are few students those are not regular in their classes, so in that case beta you'll not be able to understand. Okay, so just give me a second and let me take the attendance before we can wrap up of this session.